wanted you to do. I'll take them up if you've got any questions, comments, concerns about them. If you didn't manage to get them done, you will have a little bit of time because there's going to be review coming up here. Here's your first one. It was about the worms. Are there any questions, any confusion about the worms? I'll look like this, worms and polar bears. Comments, questions, concerns about the worms or the polar bears. Or if you worded something different than I worded it, don't assume that I am right and you are wrong. Let's talk about, especially in biology, don't assume. Yeah.
Well, what if just die? Like maybe the babies have a higher chance of dying. I put
For which? So like, hold on. Talk to me about what are we talking about here?
Like where it says some variations are favorable, you just said thick is warmer. I didn't put any. Yeah.
I'll add thicker is warmer. Like the thicker, I mean, even that in my mind accounts for the mediums. Like the thicker the fur, the warmer it'll be, and so there will be. You're right. Some mediums are going to survive where the thin fur wouldn't, but mediums wouldn't necessarily survive as well as the thick fur. So sure, yeah, I can make that thicker fur. Call it a spectrum.
And then for where it says more often survive,
I think for that one, the way I understood the wording of that question was, you're talking about the more offspring are produced in this sort of like actually looking at where is that true? How is that demonstrated? Well, there's 2 born and 1 survive, kind of thing. Like it's looking for those specific. Same thing with the worms, like that. It doesn't. I don't think it matters at this stage. It's not talking about which ones survive necessarily. It's just talking about the volume of production. You need to have more than 1 offspring for natural selection to be a thing, and it doesn't have to be per mom either. Like the ostrich one, each mom's only laying 1 egg, but a flock will have a bunch of offspring. As long as some survive within the flock, then you're good. So are we cool with the worms and the bears? Okay. Okay, here's the ostriches and the rabbits. There, that's all of it. Why is this not working? Remove. Yes. Add back in. Video capture. Comments, questions, concerns on these 2. Okay, so we're talking about the rabbits then. It says more offspring are produced than survive, and it says here in number 4 that the rabbits have babies all year long, but many are eaten by fox or hawks. So when you have an animal that has a breeding season, like the polar bear, they might only have 2 a year. 1 survives. The way the rabbit deals with more offspring are produced than survive is that the rabbits don't have a breeding season. They just crank out baby rabbits all year long, and that's just how I worded it. But that's the context that they're talking about there. Okay, comments, questions, concerns. Going once, twice. Yeah. Because the offspring, the more offspring produced than are survived, it's not referring to like what's necessarily being selected for. It's, I mean, to a degree it might, but it's talking about you need a volume of offspring that express a variety of traits to start talking about how populations change. I don't know if that actually answers the question or not. Okay. Okay. Comments, questions, concerns. Okay. Then let's look at the mods. There's my graph for the mods. I started trying to make it a bar graph, but then it was clearly not working for me. So I changed it into a line graph. The dark you can see, it's just taking a look at what you've got here and watching the population grow. You've got populations of dark mods that are increasing. You've got populations of light colored mods that are decreasing. That's really all it wanted you to see. And it's easier to picture it as a graph than just, for lots of people, it's easier to see it as a graph than just raw numbers. So questions about the graph? Okay. And then there's a whole bunch of questions about the graph. And so, there's multiple ways to answer these. This is just how I chose to answer them. What process occurred? Natural selection. These are gimmies. Like these are textbook questions. These are like underhand, slow pitch, softball, big arcing, slow pitch, right over home plate, crank it out of the field kind of questions. Easy. We play soccer. I played beer league slow pitch with Mr. Kidd. We were on the Brew Jays. It was awesome. Okay, so the process is natural selection. What is shown in the graph? Population increased in dark mods. Light mods go down. As the pollution went up, the dark mods increased, the light mods decreased. Number 4, name one factor that caused the decline in the number of light-colored mods. They lacked a place to hide. So if you read the paragraph above where you graphed the thing, you would have seen that the pollution killed the moss on the trees and then covered the trees. If you don't know anything about birch trees, they're white. And so if pollution covers a white tree, now the tree looks dark, and now the dark-colored moths have a place to hide where the light ones don't. Is what it was getting you to look at in that paragraph you were supposed to read. Which is basically the answer to number 5. Explain why there was an increase in dark-colored moths. They had a place to hide. They were harder to hunt. Pollution was covering the white surfaces of those birch forests. What factor influenced the survival of the peppered moths? I said color. Color was the trait that was being selected for or against. What gave rise to the dark-colored moths? The pollution. What would you expect to happen if the frequency of dark-colored pepper moths, if regulations reduced air pollution? So if the air pollution was reduced, there'd be less of it to coat the trees. It's realistic that the dark-colored moths population would drop. Regulating air pollution doesn't get rid of it entirely. So the dark-colored moths would drop, the white-colored moths would rise. Who knows? Maybe they would meet in the middle. Maybe there would be situations that favored both of them equally. I don't know. But it was just a speculative, give me some reasonable thought, I'll probably give you the correct answer kind of question. And that's a lot of what biology is. Like justifying your answer, especially in this section. Less so with meiosis, mitosis, a lot so here. If you can give me some justification for your answers, you're probably going to be fine. It's not like chemistry where you're like trying to justify why you wrote the chemical formula wrong. Like there's no justification there. You got it wrong. I added 2 and 3 and got 7. Let me tell you why, and I don't care why. It's wrong. That's not entirely true. I do care why, but it's still wrong. And then number 9, how does the pepper moth example illustrate that natural selection is situational? The way I answered that is I said it only happened in areas with pollution. Like it's not like it was a blanket death wish to the light-colored moths. So I don't know. There was lots of ways you could have answered that. Comments, questions, concerns? It gets worse when we talk about the next question because there is no paragraph. You're just making deductions based on islands and bird beaks. Okay. Here we go. These are the Galapagos Islands and the finches found on those islands. I referred to it yesterday as an island chain. Those are them. There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. Gives lots of different places. And again, if you're not into animals or have spent any length of your childhood into animals, these questions could have been quite difficult for you. If you have some experience just being interested in birds and looking at ecosystems and not just playing video games, but getting outside and going for a walk in the woods and paying attention to what's going on around you, these questions aren't so hard. If you played a lot of Red Dead Redemption, you're probably okay here too. But if all we're doing is playing Call of Duty and Fortnite, yeah, these are going to be difficult questions for you. So, here we go. 2 selective pressures experienced by the ancestral population of finches. I said there was 2 things that were kind of mentioned. The fact that those islands are isolated and the kinds of foods that were available. There's other answers you could have given here. But that's what I talked about. What characteristic came from the selective pressures? Different beaks is the one characteristic that you're talking about in this scenario. 2 factors that influenced variations in these characteristics. I said ecosystems and food sources. And that came about from just looking at the bird populations. There's tree finches and ground finches and cactus finches and a particular island finch, the Cocos Island finch, that led me to suggest that ecosystems and food sources were the issue. And then what led to speciation? Specifically the food sources is what led to speciation. These next couple are debatable. Which would I expect to have a thick beak to break large hard nuts? I said tree finches, because that whole class, there's 4 different species of tree finches if you look at the previous page. Those are the ones that I expected to have thicker beaks. And you can see it in the pictures. The stabbing beak, I would assume, would be for insects. It's the same conversation we had. If I changed the bean food source in the game that we played 2 days ago and released beetles in the class and told you to collect those instead, the tweezer people are probably going to have a better time with the beetles than the spoon people. Fork people would have been good too, but the clothespins and the spoons would probably have died out if we're collecting beetles instead of, because forks and tweezers lend themselves to stabbing. I'm not releasing beetles in my classroom. That is just a hard no. Evelyn, you want to release bugs into places? Take University Bio. You'll have an opportunity to play with bugs. Where are we here? What food sources would I expect the finch to have? Oh yeah, we talked about that one already. Could 2 species coexist? Yeah, you bet. As long as they're eating different things, there's no reason why they couldn't coexist. They're not competing for a food source. They're not competing for the large cactus finch is eating cactus seeds, and the cactus finch itself is eating insects. Absolutely, they could coexist. They absolutely could mate too. They're both types of cactus finch. There's no reason why we couldn't expect them to be able to mate. Brooklyn, we're good, yes? We're not just on social media. Would I expect larger islands to support more or fewer species? I said more. The bigger the space, the more likely the variation in ecosystems, food sources, places to live, etc. Question 9 looked like this. Suppose a population of tree finches, yada, yada, yada. I predicted that they could coexist. Again, different food. 10, of the 4 ground finches that live on the island, which finch would have the adaptive advantage during the drought? Explained up here. I said the medium or large would be most likely to survive. The frequency of all of the ground finches would decrease. Good morning, Massey. I said the average beak size due to natural selection over time would increase. The average beak size would get bigger. 11, it says, as larger seeds become scarce, what finches would have now an adaptive advantage? I said the small or sharp beak ground finches. And I said that it suggests some factors that could lead to the extinction of these finches if the food sources disappear or the ecosystems get wiped out. Ecosystems change is what I could have put in here as well. And 13 said to come up with some questions, and I didn't feel like doing 13, so I crossed it off. You also don't have to do 13. Unless you already did 13, in which case you are a better student than I am right now. Questions, comments, concerns about any part of natural selection? We should do it again? It's hard because they're all just forms of seeds. It really is still going to continue to benefit the same. What if it was rice? You want me to spread Jell-O over the floor of my classroom? No. I'm not even going to entertain that discussion. Just no, unless we got a tarp. If you brought a gigantic tarp and you made the Jell-O, you'd have to make a ton of Jell-O. I'd still probably say no, because it would just turn into, I don't want people going through the school being like, yeah, there was Jell-O fighting in Deweytoff's science class. That just isn't something I'm interested in entertaining. Yeah, but I'm thinking of my other, well, there's two problems. The other block, there's a realistic chance of getting hurt. And in this block, because, I mean, the population of this class is more skewed towards the girls, that's the kind of reputation I want my science class to have, right? We had the girls Jell-O fighting in the science class. That's not okay. That's just never going to be a thing. So no, Evelyn, I am not producing Jell-O as an option, because it's the spoons and forks again. The tweezers and clothespins will still die. You're not going to get anything different. Again, still probably, maybe. A lot more expensive than beans. You guys would want to eat those, but they'd be all over the floor. I'm still going to go with no. Well, then they just turn into beans. Okay, no. But did that activity help? Was that having had this discussion now on natural selection, was that a worthwhile activity? Yes. Okay. Here we go. If you haven't already, find me the page on artificial selection. Today's lesson is short. And I'm going to give you guys, after the lesson, we're going to do a lab today. Your last bio lab. It's going to be great. I know the bio labs are hard because it's all stuff on paper and things to read and flipping coins, but yes, imminently. Where did my box of resources go? Oh, no, I put them in here. Yes, they're there. Okay, here we go. Artificial selection. Natural selection is done. We talked about it. It happens in the natural world on its own. But artificial selection is a thing. If you have an intelligence, and if the intelligence decides to get involved in the process and screw with things, you can artificially influence how different traits get selected. You would have discussed this in grade 9. The first time you would have talked about artificial selection would have been like artificial vegetative propagation. How do people get involved in plant reproduction? And depending on who your science teacher is, there's a bunch of different ways to look at this. I've shown videos in the past of like how tea leaves are propagated. So breeding different tea plants together and getting different traits for different teas. There's a particular tree at a university down in the States that has been grafted such that a singular tree has like 40 different kinds of fruit being produced on that one tree. Because they just graft in a new kind of branch. And so a singular tree is producing peaches and apricot and plums and, I don't know, 40 different kinds of fruit. But people can get involved. Humanity gets involved, Evelyn, and crew, in artificial selection in sexually reproducing organisms as well. We are that intelligence that gets involved there. Selective pressure exerted by humans on populations in order to improve or modify desired traits. Improve or modify desired traits is the definition of artificial selection. And part of the problem here is that humans are not benevolent. But by that I mean, as a human, like humans, us as a species, we are not universally good. We are selfish. We are greedy. Some of us just like to be stupid, to be stupid and say, you know what? We have the power. What ridiculous thing can we do with it? That happens. And when you have all of these different influences and a population of organisms that can't resist, you open yourself up to a whole bunch of options and potential terrifying scenarios. I'll show you what I mean by that today. So, humans breed cows. That's one way we do this. That produce more milk. If you're a dairy farmer, you want to select for the cows that are producing lots of milk. Those are going to be the ones that you want to breed. You want the offspring of those cows, and maybe not the ones that, oh, this cow was born. This cow doesn't produce milk. Cool, no kids for you. And I mean, the cows don't have well, no, they're just not allowed to eat. Or it's not allowed to breed. That cow might be for something else. Not necessarily. They're not necessarily going to murder the cow. I don't know. You just might not allow it to reproduce. They could still, they likely could still keep the cow, but not necessarily have it reproduce. And probably not going to. They might milk it for whatever it does produce, but they're not going to allow it to continue to breed if it's not producing as viable offspring or as awesome offspring. That's one example. Chickens. Chickens are another. If you have a chicken farm, specifically a layer farm, and you want to produce a lot of eggs, and you've got chickens, if I don't know, Evelyn the chicken is only producing 3 eggs at a time, but I don't know, let's pick on someone else. Brooklyn the chicken is producing like 8 to 10 eggs at a time, and they are of equal or better quality as Evelyn's chicken eggs are. Yeah, Evelyn's gonna become Sunday dinner, and Brooklyn's going to be allowed to survive to lay more eggs. Like, as a chicken farmer, realistically, that's a possibility. I have buddies who are chicken farmers. It happens. Another example of this is things like pigs. Pigs with larger muscles for meat. We breed crops. Different crops are bred for different purposes. We want them to resist drought. It might not be GMO, but it is not unreasonable. Like, so we talk about no GMOs. Well, what do you mean by GMO? Genetically modified. Is selective breeding an example of modifying the genetics of something? Well, maybe. What you could argue that you're genetically modifying the organism. One could argue. But you want them to resist drought. We want them to resist disease. Maybe we want them to resist insects, insect infestation. And so we select for plants that are more likely to survive and still produce what we want them to produce. There's different species of blueberries. There's different species of raspberries. There's different species of strawberries. I worked at a berry farm for a long time while I was in university, 7 or 8 years. And I was involved with the planting, the fertilizing, the watering, that side of the berry farm. And so you learn, you have these conversations like, well, I don't want this variety of strawberry because even a little bit of rain on this strawberry will make the berry rot right on the plant. We don't want that. We want a berry with firmer skin that resists the moisture and the rotting. And so that species gets turfed and a new species gets brought in. And then you're making these different varieties of these different kinds of berries. I had a buddy who worked at the farm with us, And he was a UFV student in the agriculture program that was actively trying to produce new species of berries. I don't actually know, because his crops were in a special part of the farm that we weren't allowed to go to. And he was working on it for like, I want to say like 5 or 6 years. He was working on it the whole time I was there, as a master's, first as an undergrad and then as a master's student. Like this was his research. Through selective breeding, the wild mustard plant is a fantastic example of this. All of these, so this is a wild mustard plant here in the middle, the common wild mustard. Mustard is not just a spread that you get out of a yellow container. It has to come from somewhere. Well, you crush mustard seeds to get it. But by breeding mustard in different ways and selecting for different traits, we've made all of these different plants from wild mustard. Broccoli, cabbage, turnips, kale, cauliflower, and this thing called kohlrabi all came from the wild mustard plant and us selectively breeding it. No. Mustard it's a plant that you harvest its seeds, crush it into a paste, and then it's a spread. Sorry? It's not a tree, it looks like a, I don't know. Yeah. Like this should be pretty wild to you. Like the singular mustard plant, we bred it to make these 6 different veggies. Turnips, cabbage, broccoli, kale, cauliflower, and kohlrabi all came from that singular plant. Wild. And by selecting for different things, you got different kinds of different kinds of plants. You've made different species. Another example of speciation artificially. Possible consequences of artificial selection. If you are selectively breeding and you're not doing it in a thoughtful, kind to the organism kind of way, you can selectively breed animals to the point of health problems. There's a reason why, so bulldogs have respiratory issues. German Shepherds, other large dogs, have hip problems because they have been interbred so aggressively for purity of strains that they've got hip problems. So if you want to avoid that and still want a large breed dog, that's why crossbreeding is now becoming more of a thing. Making a doodle, golden doodle, Bernedoodle, all the doodles. Oodle means it's bred with a poodle. So a Bernedoodle is what you get when you breed a Bernese with a poodle. A golden doodle is what you get when you go a golden retriever with a poodle. A Labradoodle, a golden lab, black lab, brown lab, yellow lab with a standard poodle. And you get traits, you start to weed out some of those hip issues, and you get hypoallergenic dogs because the poodle doesn't shed like those other breeds do. Yes, Evelyn. No. That's never going to be a thing. See, when I said that people were not benevolent, that there is a portion of the population that is just stupid, these are the people I'm referring to. Okay, we're almost done. Let's not take a deep dive into the weird parts of the internet. So that's dogs. And I'm going to show you examples of dogs here in a second. I got lots of pictures to show you. Selectively bred plants can lack genetic diversity because they're all similar. I told you yesterday, bananas. Bananas are an example of this. Put your phones away, Brooklyn. Bananas are an example of this. If there was a global disease of bananas, we would lose all of the bananas because they are all they're clones. They're all genetically the same. And an example of this is what's called monoculture. Monoculture is the repeated planting of the same varieties of species, and monoculture can lead to a lack of diversity, weak genetics, and possible extinction. To a degree, but you have to balance that with still having that genetic diversity. So, like, for example, again, we'll take it back to the berry farm. I don't know if you realize when you go to the grocery store to buy raspberries, they don't list them as different kinds of raspberries. But when I was working on the berry farm, we had 7 different varieties of raspberries, all in the fields, kind of scattered rows apart. And so you're going to get interpollination between those different varieties. And the different kinds of fruits, they tasted different. They were ripe at different times. Like there's different varieties which you don't really pay attention to. You just go to the grocery store and buy raspberries. Same thing with blueberries. The blueberry farm that I worked at, or the farm that I worked at, had 5 different varieties of blueberries. We had 4 different varieties of strawberries. We had 3 different species of corn. We had 3 different varieties of blackberries. Like they come in varieties that you don't think about just as a consumer. And so even that is a way to say, Evelyn, like I'm keeping a blackberry is a blackberry is a blackberry. Like they'll taste similar. And when you pick them, you just kind of let them all mix and mingle. Because when people go buy fruit, you buy fruit with the understanding that it's not all going to be exactly the same. But you are going to have a consistent experience. The reason you have a consistent experience is because when these things get processed, they get processed and then allowed to intermingle so that, oh yeah, here's raspberries. And you don't really pay attention to the fact that there's 4 different kinds of raspberries in the bowl usually, for example. So examples, this is it. This is the last lesson. Examples of this, if you flip the page now, all I've got are picture examples of these kinds of things and stuff that I've already shown you. So I'll show you the color versions of these, and then I'll show you the images that I found of some of these dogs. This is what watermelon used to look like and what watermelon looks like now. Very different. This is bananas before and after. Because they were artificially selected for. They were bred to have a particular trait. These are all seeds and not a lot of flesh. Bananas were bred then to have very, very small seeds or no seeds at all and lots of flesh. So that it was artificially selected for, and over time, by choosing what plants were allowed to continue breeding and cutting down the other ones, we made these bananas and got rid of these bananas. Yes, Evelyn. I honestly, I don't know the answer to that. The more, I know definitely grapes. How can you have a seedless grape? How could a seedless grape reproduce? There's no reason why this process couldn't have started thousands of years ago, yeah. It doesn't take a rocket scientist to say, oh, that particular example of this species is bad. Cut it down, throw it away. That's a whole nother conversation. Let me show you an eggplant. Totally unrelated to Brooklyn's question. This and this, same fruit. This is both a carrot. Wild carrots, not wild carrots. Very different. Corn. Corn, very different. The same process. Allowing things to breed in particular ways. Let me show you so here's the pictures that I wanted to show you. This is what we have done to dogs. Okay, let us zoom. Let's go this way. Okay. So this is what pugs used to look like. They used to have a longer snout. They actually looked like dogs. Here's a side profile of a pug. It actually has a nose and a tail. And then people got involved and decided to be stupid. Now the tail has shrunk, the face has been pushed in, and in horrible examples of the pug, you get this little freak. And they can't breathe. Like its entire existence is suffering and misery.
That's really sad.
It is.
No, it really is. For what? Vanity?
Yes, for vanity. That's all it is. Here's another example. Pugs. Where's the picture? Here we go. This is what pugs looked like in 1878. This is what a pug looks like in 2020. This is the change. In 140 years, COVID had nothing to do with it. Don't you dare. Here's what the skulls look like of these little freaks. This is what dogs like. Oh, your OG dog population. Your wolves, your huskies. This is what the skull of a canine should look like. This is what breeding has done to these poor little animals. They'll have the same skull shape as these guys do. Where's my mouse? Like any of those, you're picturing the same kind of snout, the same facial structure. Yeah, your classic canine structure is all going to look similar to these. That's why they're not included here. I thought I had another one. I don't. I just those three. Okay. And so you can see, even if this might not look like misery, like this one obviously is worse. The eyes are bulging. It can't breathe. Like that's really eyes have popped out of pugs' heads. This is what a pug could have been, and even a snout like this would have been more along the lines of this kind of skull than this pathetic little creature. It is really quite sad. So, this is it. No. Selecting for the mutations for longer for those other traits, you'd have to. But they've bred out so many. Like those traits have been bred out of the species, or out of the subspecies, the breed of dog. It would be very difficult to bring that back unless they started crossing it with, you can make a breed by just crossing it with something else, and then having that like a doodle. A doodle's now a breed because they've been, crossbred and all that kind of stuff. So, okay, so yeah, here's what I'm going to get. A summary. Here, let's summarize it all together. End biology once and for all. DNA mutations produce what? Genetic blank in a population. Sorry? Diversity. Environmental factors called mutagens can cause mutations. Natural selection favors traits that make an organism better suited for survival. Natural selection can lead to the formation of new species. Well, you guys are paying attention, so I'm just going to go for it. And in artificial selection, humans, evil humans, select desired characteristics in organisms to be passed on to the next generation. This word here, desired, should be heavily in quotes. It's whatever we decide is awesome. And it leads to a whole bunch of different things. I'll just list these traits here. Maybe hypoallergenic. You want the dogs that don't cause the allergies because you know what, people with allergies should be allowed to have dogs too. So you breed everything with a standard poodle, and you make an animal that doesn't shed. Maybe you want to breed for intelligence, which is something that you guys are going to look at in your lab. How many of you guys are aware that our French teacher in the building has a dog at school with him? We are aware. Yes, Scarlet is her name. Scarlet is not his first dog. He's had a number of these dogs that have been trained to be different kinds of service dogs. And he did tell me the one before Scarlet, they actually had to surrender her. They had to give her back because she was so good at what she was doing and expressed all like the right temperament, the degree of intelligence and education, willingness to learn, and all of those traits that they want in a service dog, that the service company took her back, and now she's a mom. Like her sole purpose is to have offspring that exhibit her traits. She is no longer an active service dog. She is just breeding. Because they want more dogs like her. Sometimes you want aggression. Aggression has 2 G's. And different kinds of aggression. If you want a dog that is going to protect your flock or whatever from bears, from wolves, you might want a hyper-aggressive dog. You want a guard dog. You want it to be super aggressive. You want a family dog. You don't want it to be aggressive. You want to breed for different traits. And then all the vanities. Cuteness, color. Oh, yeah. You can have dogs. There are different breeds of dogs that are definitely more or less intelligent than others. And there's sweet spots for intelligence. If a dog is too smart, that could be a problem too. Huskies are just disturbingly intelligent. Too intelligent. They'll get into all sorts of random crap if they're allowed to be in home. A husky's job is to be outside. They are working dogs. If you allow a husky into your property, into your living space, they get antsy and they are freakishly intelligent. Annoyingly intelligent. But Dalmatians are stupid, for example. The average intelligence of a Dalmatian is not what Disney would have you believe. But they will do what they're told, which is why they brought the fire dogs. They're not smart enough to be like, this is dangerous. They'll be like, we're going, we're doing it. They're big, they're strong, they have a role to play, and they're not smart enough to realize that they're putting themselves in danger. So you've got all sorts of different kinds of traits that you want to breed for against these different breeds. And they all have different roles. I have a Disney movie for you. Go watch the 101 Dalmatians and you will get. You can watch. Movie night at Evelyn's. Everyone's invited. Okay, so we are done. Here is what you guys are going to start with this. The 1.3 assessment. It's just multiple choice. You do not have to do question number 25. Once you have finished the 1.3 assessment, I want you to come over here, because there's 25 minutes left, there's lots of time left. I want you to come over here and I want you to grab this. Maybe make you could sew. I like that. I would. This is your guys' lab that you're going to have today, tomorrow, and the weekend to work on. And if you do manage to get it done, the reviews will be available for you tomorrow as well. This particular activity, I'll explain it real quickly here. Okay, so you guys are going to do an artificial selection activity after you're done these questions. The activity looks like this. Here's your assignment. You're a dog breeder. You've been contacted by a scientist working in the Arctic. Arctic, there's extra C in there. The scientist wants a dog that will be able to hear a polar bear approaching and alert him with a loud bark. This could also help to scare the polar bear away. Part 1, there's a table on here that says desired features of the new breed. Based on the task, you're going to go and look and you're going to say, okay, for each of the features below, circle the desired form you ideally want your dogs to have. Given just the fact that you want a dog for the Arctic that will hear a polar bear approaching, alert the scientists and scare the dog away, you're going to select for coat color, fur length, ear, sight, smell, endurance, behavioral traits like trainability, bark, and disposition. You're going to pick which traits, and for each one of those, I want you to explain why you've chosen that trait. If you need more space than I've given you, I've only given you like a chunk of the page to talk about why. Some of you are really good at giving me short answers. Some of you want to write a small novel. If you want to write a small novel, I have more blank paper or use your own blank paper. For each feature you select, explain why the trait would be helpful to the Arctic scientist. Then, if you flip the page over, when you flip the page over, you're going to see part 2. Dog breeds chosen to mate. That's where you're going to go look at this particular page here. You guys have 6 breeds to work with. Based on the traits that you've chosen, you're going to choose 2 of these breeds to cross. Try and get your desired traits. What are the reasons that you've chosen to mate your 2? Which traits do you think are most important for your new breed to inherit? And now you're going to actually allow those dogs to breed. Part 3 says, remember our study of genetics and how the offspring receives one gene from each parent randomly? You guys are going to flip dominoes. Again, to determine what traits, whether it's the mom's trait or the dad's trait they're going to get. So, if you choose, for example, if you choose breeds A and B, all the traits of A are listed there, all the traits of B are listed here. You're going to flip a domino to determine, well, is a singular offspring going to get the medium coat? With the short fur, the medium coat, the white coat? Which traits are going to show up from which parent? And I took a poll of, I think it was the other class when I was making this. Editing, I didn't make it myself, but I edited it. Someone told me that the average litter size is like 9 puppies. So y'all are going to make 9 puppies. Lots of coin flipping. How many, and then once you've made your 9 puppies, how many, if any of these puppies from the first litter have all the traits you wanted for the original task in the Arctic? Are any of them closer to the goal than either of the parent? How could you continue the process to end up with the dogs, with the traits in the dog that you? No, I said you would have today, tomorrow, and the weekend to work on. So, you only get to pick this up once the multiple choice questions are done. Except for me, you can have that. And then, yeah, this will be, we're going to have a short block tomorrow. Well, actually, you guys have a short block with this tutorial. Okay. Okay. Put your phones away, you have a task. Get those done and then come pick up your dog breeding lab. This will need to be handed in next week. I don't know, I decided it's going to be Monday or Tuesday. Sorry? Yes, the quiz is going to get back tomorrow. Because there's some people who still have to write their own score. Scores are on my end. Which question? In which the following situations would include mutations here in the population size? Okay, so look back. Mutations occur in DNA during DNA replication. Flip over. Which of the following situations would mutations disappear from the population size?
From the population of the organisms that well, it can't be A and B or A and C because those are effectively the same. When they occur during meiosis. If the problem occurs in the meiosis portion, then the mutation would disappear when the organism undergoing meiosis with the mutation dies. It won't be allowed to pass on its mutation. Does that make sense? Okay. Which of the following mutations can be passed on to future generations? Yeah. C would be the correct answer. Because well, what's being passed? Look at like being passed on is the key there. I mean, if the mutation occurs in your brain cell, just your brain cell, you get brain cancer. Is that going to be passed on to your kids? No. Right? Like, it's the only way that you're going to pass that on is if there's something going on in your eggs or the sperm of whoever your partner is. Sure you said. Q3. I've got everything. It was rough for a lot of people. It was rough. Don't worry, we'll go over it. Hold on. Tuesday. Okay. Perfect. So I will admit it. You will not get it. Did you still have questions or should I keep walking? Okay, you guys are good? Are you? You don't seem good. These ones aren't individuals. These ones like the key is passed on. The only way something is passed on generation to generation is if it shows up in a reproductive procedure. Meiosis. Yeah. A selective advantage, an advantage is a positive thing. It would be an increased chance of survival. Yes, an advantage means you're doing better than you were before. You're finished, all of them? Okay, then yes, take the dog breeding activity. Yes, amatoge. Okay. Oh, this one. So, cigarette smoke. Yeah, chemical. Cigarette smoke is going to be chemical mutagen. And there's 20, which we call them, for example, physical mutagens. X-rays and ultraviolet radiation. I don't know. You know what? We're going to define that. What is it looking for? The definition of a physical mutagen. They're all mutagens. No, maybe they're not all mutagens. Oh, yes. Okay. So. Not these. A physical mutagen is something that is a mutagen, so something that can cause mutation physically in an organ. Preservatives aren't designed to do that. It would be like, but I mean, my arms. the one that hangs out the window when I drive. This is the one that doesn't. You can see the sun has had an impact on this one. This one doesn't have the same. Same thing when we talk about dental x-rays. Yes, bro.
For number 8, it says natural selection estimates for following. Is it going to be individual?
I don't know. I don't know. Well, what is the goal of natural selection?
Helping survive.
What's
To
the
adapt. Population.
population? It doesn't care about the individual. All it cares about is that the species survives. Yes, that one. Read, go back to the Bible. God is genetic. Yes. Sam, can you grab the in that drawer that was open there on my filing cabinet is the container of Dominoes. Can you get that out and put it? Yeah, that guy. Open them up and throw them next to the beans. Please, thank you. Goodbye, Minnie. Right? If you have an advantage, that's a positive. Don't say something. Where's what the screen doing? That's the argument about the situationalness of natural selection. If right now you have an advantage, right now you're gonna have a better chance. But natural selection is that what I was making the argument, what I was suggesting here is that is not going to be universally true all the time. There is a possibility where an advantage that you have in one scenario becomes a disadvantage in another. That's what this section is addressing. Physiological process that helps organisms survive and reproduce in its environment is known as why is it DO? It is an and it's a singular organism. That's the key there too. Like,
okay, yeah.
the fact that it's a singular or something that allows a singular organism to survive, that's an adaptation. Why do you want points? I don't know. That's true. I don't know. If that were true, it would make sense. I mean, you're probably going to hear better than Bob here. Yes. Oh, it's kind of it's a fluffy. It's energy, and then they bring in radiation to it. It's a necessary unit to teach. Like I think it'll ultimately be more useful to teach these guys that than space, but I think space is good. Then the physics unit. Like the science, yeah, the science 10 physics unit, we do it in a day. In physics 11, like the whole unit, you could do it in 2 or 3 days, really. So that's why I've always been kind of meh about it. Yeah, no, like as a general, like teaching Science 10 is one of my favorite courses to teach. There's a variety there. There's a lot of cool stuff. I mean, especially if you're taking the time to do the labs. If you're no, it's can be a really cool course to teach. Okay. Okay. Hey, what do you got? In the bin, please. Yes, in the bin. Okay. going to go at some point in the next minute and a half. If you didn't get a chance to grab the dog activity, it will be available to you tomorrow. We will take up these questions next time I see you. If you did not write the quiz for me last week, you need to write it tomorrow during tutorial. We'll make sure that happens. This. And you guys will get the chapter review tomorrow as well. Your guys' chapter test is going to be Wednesday next week. Because Tuesday we have a pep rally, so the blocks are all shorter. Next Wednesday you guys will have your biology. Next week, Wednesday. Yeah, you too, man. Bio test gets the dynamics. Yes.
Brooklyn and I will be here. Oh yes, we are not going to be here tomorrow. Oh, me too. I'm helping with the grades.
Okay, then take this.
I got mine.
Okay, and review.
Well, be here for tutorial.
Okay. We'll take it either way. You'll have
Tutorial's first bucket ends at 10:15.
Oh, and yeah, we're ending at 10:15.
And take this, and I will see you guys tomorrow.
Okay, bye-bye.
Thanks for letting me know.